We are delighted to welcome another great leader in the field, our first keynote speaker for today. Joining us from Mountain View, California, remotely, Dr. Greg Corrado. Greg is a distinguished scientist at Google Research. He co-founded the Google Brain team in 2011, which has helped catalyze the broad adoption of deep neural networks across technology companies worldwide. Within Google, he has spearheaded teams that apply deep learning to various applications, including image recognition, machine translation, text synthesis, and recommendation systems. Dr. Corrado has a strong publication record in various fields, including behavioral economics, systems, neuroscience, artificial intelligence, and scalable machine learning. He has a deep and abiding passion for applying AI for social good and presently leads the Google Health Research and Innovations Division and the Imaging and Diagnostic Product Pillar. Greg did his graduate work in neuroscience and computer science at Stanford University and his undergrad studies in physics at Princeton University. Please join me in welcoming Dr. Greg Corrado.
Thank you, everybody. It's really a delight to be here, only virtually in this case. One of the wonderful things about this symposium is that I really believe that the topic of deployment is the bottleneck right now for actually having these technologies have a positive impact on the world. And the team that I lead at Google right now, funnily enough, is simply called Health AI. So when I was making my slides, I realized I should probably qualify that sometimes I'm talking about Google's Health AI team as opposed to the Institute's efforts overall. As was mentioned, I've been at Google for a while now, and I helped get the Brain team started, which is where I met and started interacting with Jeff Hinton, who had a profound impact on not only the field overall, but Google's research directions and really my direction and career as well. But for the last several years, I've been working almost exclusively in the health domain, trying to bring these technologies to bear. So I'll make just a little pitch for what it is that the Health AI team at Google, what our mission is. It's a research group, and it's really about trying to catalyze the adoption of human-centered AI in healthcare and medicine. Fundamentally, I believe that organizations like Google have a lot to offer in this domain to be able to show how these technologies are useful and can be used in the real world. I want to make an obligatory reminder, just so that we're all on the same page, about why is AI ML a big deal. From my point of view, it's really about a new computer science fundamental in terms of how we build machines that do things. And it really comes down to the realization that the notion that we can solve things in the world with handwritten algorithms that identify and distinguish stimuli in the real world was naive. And you might think that you can write an algorithm that successfully discriminates puppies from muffins, but the real world is a little bit more messy, and sometimes it's actually pretty difficult to tell the difference. But the fundamental promise of machine learning is that simply by learning from stacks of examples, you're able to deal with these hard, unexpected, and sometimes entirely unforeseen cases of overlap between classes in ways that you wouldn't have imagined. And this has really been the cornerstone of how we've built technology at Google, not only in the image recognition space, but speech recognition, translation, and a whole bunch of other things. But when it comes to healthcare, I really think it's very important to not confuse intelligent automation with human insights. And I do believe that the machine learning has a role to play in both of these. But fundamentally, I view machine learning as a partner to the field of data science. And in the field of healthcare broadly, I feel that not only is machine learning and artificial intelligence offer a lot of promise, I actually feel that there's an enormous opportunity for the use of data science in healthcare systems in order to improve their efficiency and really have a system that learns from its own behavior. But all of this rests on the clear instrumentation of healthcare systems and having data available in a privacy-preserving way that we can either do analysis or do machine learning on. And the fundamental problem of garbage in and garbage out on these kinds of systems still holds true. And that is actually, in my view, one of the greatest blockers to advancing these technologies. I just want to offer my opinion about how I think that AI and ML is really going to work in the healthcare domain. I'm not bullish on the idea that we're going to digest mountains of data into groundbreaking clinical insights. I think that that's the domain of data science. And I don't really think that it's about applying superior reasoning to crack the toughest cases in some sort of Sherlock Holmes fashion. But that the lion's share of the positive human impact here is going to come from recognizing patterns and offering data-driven outcome forecasting, and by automating the things that are truly routine, but being an assistant that's able to catch things that are commonly overlooked. And I think that these two paths will allow us to both put more of an emphasis on preventative care and expand the accessibility and availability of services at the same cost, and radically improve their accuracy. So I think that there's a lot of value, but the actual process of getting these things into practice, as you're all aware, is quite difficult. So I wanted to share some of our real world experiences in the Google groups at taking machine learning and AI systems, trying to deploy them in the real world, and then share some of the learnings that I think that we've had from that. So one of the most mature programs that we have at Google is one where we've used computer vision to help in the screening for diabetic retinopathy in underserved populations. So diabetic retinopathy is a complication of diabetes that can lead to permanent vision loss. And in much of the world, there's a real shortage of doctors who are able to provide the screening in order to narrow down the population that actually needs treatment. And so years ago, we set out on the idea of, well, okay, is this something that can be automated? And we took what we thought was a reasonable approach of using the kinds of computer vision models that we had trained for other object recognition tasks at Google, and getting some great data from partners who were in the same community where we actually thought this would be most useful. So we got data from eye clinics in India, where they had a real shortage of doctors, and built a system that was able to make very reasonable predictions from these images of the back of the retina. And we wrote a paper about it and tried to describe to the best of our ability, how to do this. And it was very well received at the time, and went on to be nominated by the editors or chosen by the editors of the Journal of the American Medical Association as one of the most impactful papers of that decade, which was an enormous honor. But at the same time, sort of foreshadowed a little bit of the frustration that we experienced in then trying to deploy these technologies into the real world. But that's what we've been focused on in the intervening 8 years is working on deployment and understanding how these systems work in the real world. And we've done a fair bit of it now in locations around the world, mostly in Southeast Asia and a little bit in Europe. But actually bringing the technology to the point of care has been both incredibly rewarding and also created a lot of opportunities for us to learn. So one of the first things that we realized was that we really needed to take the process of deploying a technology and streamline it so that you're able to actually scale your deployment in a way where you're not investing a constant amount of resources for every eye hospital or screening site that you're trying to do. And we were able to see that over time we could dedicate less and less of our own time in order to help new sites get set up, in order to be able to use that technology, and that allowed us to kind of create a large enough network of sites using this technology in India and in Thailand that we could really start to see what volume looked like and begin to analyze these data in an ongoing situation in order to improve the situation and understand how it would work. Now, in order for this to be successful, we found that really needed to be a partner-led deployment approach, one where we, the team that we support is relatively small and nimble, but is helping the folks who are really in need build these systems out for themselves and get them running in the real world, and trying to align with national screening programs about how it is that the technology can be used and put in their hands and in the best way to help people. Before I get to some of the learnings, I want to talk to you about another example where we see some differences and some similarities. So we worked with our colleagues over at DeepMind Research in the UK to build a system for breast cancer screening, looking at mammography imaging, and we were able to show non-inferiority to human radiologists screening for breast cancer, which is now actually the most common cancer in the world. It surpassed lung cancer. I think just this last year is the most common cancer, and that's not. That surprises some people. They think we're saying it's the most common cancer in women. No, it's the most common cancer in people. And being able to show that this system worked as well as or screened as accurately as radiologists did was exciting and was promising. But again, you face the challenges of bringing this into the real world, and it was kind of a non-starter in a lot of ways to imagine taking an active screening program and saying, okay, well, let's just switch over from human radiologists to an artificial intelligence-based approach. But instead, what we had to do is we had to look at the actual workflows that were used in real screening programs and try to understand how the technology could best be used in order to aid what was being done in practice. So in the British National Health Service, the standard of care is actually that every patient's mammogram is read by two human radiologists, and then if they disagree, it's sent to a third radiologist who arbitrates or tries to reach a consensus. And so in this setting, one of the opportunities that really fit well with the ethos of the healthcare system was to say, okay, well, let's try putting the AI system in parallel to the human, so having it replace one of the two readers, and then allowing the human and the AI to either agree or disagree, and then send it to a human for consensus. And one of the things that's very attractive about this is that it allows us to continue a standard of care where every image is read by humans, and we actually believe that it leads to an improvement in quality because the failure modes of the artificial system and the human system are often complementary, while improving efficiency and reducing costs by nearly halving the number of human hours that are required. But this is still something that's under study in the real world in terms of actually measuring the endpoints and how big of a difference does it make. But that's just one example of how you can apply the technology. We were actually able to take very much the same underlying machine learning model and apply it in a very different way by thinking about workflows overall, not just about taking an existing diagnostic workflow and replacing a single component. And this was actually motivated partially motivated by something that occurred in my own family. So this is my daughter Astra, and this is her grandmother Gaga. And Gaga needed a mammogram. Gaga got a mammogram, and the initial results came back with an abnormality, and she was told that she needed to schedule a follow-up visit. But that follow-up visit wasn't feasible for 2 weeks, right? And so in that period of time, right, you're taking a patient and you're making them wait for their results in a time when there's actual cause for concern. And even for patients who, like Gaga, fortunately have subsequent studies reveal that everything is normal, there's a real stress on those patients. There's a lot of discomfort and anxiety, and it also puts an additional burden on the healthcare system in order to schedule multiple appointments for people. So we had the idea that, maybe what we could do is, and her experience was not unique. It turns out that in the US, the median time between the primary study and a secondary study, if the secondary study is indicated, is 2 weeks. So her experience was right on the dot. But what if we could use a model in order to do real-time prioritization, where we could perhaps surface mammograms where we would predict that human radiologists would order a subsequent study, send it to a human radiologist immediately, have them validate that, yes, they would order a secondary study, and then offer the patient the opportunity to do the second study the same day before they're even out of the examination room. And that's exactly what we've been doing with Northwestern Medicine, where we're actually doing, I believe, the first prospective randomized control trial of an AI algorithm for improving outcomes. And our primary measures are trying to look at, well, does it shorten the time to diagnosis, and does it either support or improve accuracy? And we've got that in submission now, and I can tell you we wouldn't be submitting if we didn't think the results were pretty good. But what are we really learning as we're doing these various things? As we're trying algorithms in the way that we thought they were originally intended, as we're trying them in new ways in the workflow, what are the core things that I think that we're discovering? So one I think reality check for us was that I think going into it, a lot of us were really thinking about data quantity, and that getting access to larger and larger data sets would be what would drive model improvements in accuracy. And we've really found that the quality and diversity and label quality, that's actually where most of our improvements have come from. It has not been through just sheer volume of data. We've also seen that, I think that making these things work in the real world, you can have the best AI experts, but the reality of the system is that you need a multidisciplinary team that's familiar both with the underlying computer science and is familiar with healthcare, and where the level of communication and respect within that multidisciplinary team is at the highest levels, because the problem is fundamentally quite complex. Another thing that I think that we've, was alluded to in the introduction is that I think naively we would have all hoped that, great benchtop performance would lead to adoption. And that's really That's really not the case, and part of that is a cultural difference, an impedance mismatch, and something that I believe is appropriate, right? I think that the tech ethos of trying to move fast and break things does not apply to healthcare, and we really have to move carefully and measure things as we go. And that's been, I think, part of the tack that we've taken more recently. I think, and the other thing, which is sort of foreshadowed by our experience in mammography, is that just dropping something into a workflow is not how things happen in the real world. The fact is that even in cases where we do think that there's a location that we're just gonna automate a step, as soon as you introduced AI into the workflow actually changed. So this was something that we saw really in spades in our work with diabetic retinopathy, is that as soon as the response time for getting something read was radically shortened, it changed the entire way the workflow operated in terms of scheduling, in terms of sequencing even, because humans naturally react to what's to a change in the surrounding conditions, and that's actually what you want. But it means that the criteria that you optimize the system for initially may not be the case after you've introduced it to the real world. And then I think one of the most important lessons, which was pretty obvious to us going in at Google because we had experienced this in real products before, which is that getting something to users for the first time is not the finish line. It's the starting gun. And that actually continuously monitoring performance and understanding how the systems are being used in the real world is perhaps the most important thing. And so in some ways, when we talk about deployment today, we're talking about initializing the deployment cycle, and that subsequent deployments are structurally different and are very, very important as you're learning progressively as you go. And some of the kind of recently described and very unfortunate failures of some algorithms on electronic medical records have were kind of engendered by building algorithms on the benchtop, validating that they worked in those cases, but then when they were rolled out to the larger population, actually failing because the data distributions shift, schema changed, and there were just messy things in the real world. I'd like to just end by saying that I do think that there are some examples where I feel like it's also about you actually kind of change what healthcare workers think is possible when you show them new AI solutions. So this is an experience that we had working in real-time colonoscopy support at a hospital in Israel, where we found that we were able to use AI to do simultaneous localization and mapping of the colon as we were doing a colonoscopy. And that kind of heads-up display of coverage actually gives gastroenterologists a new objective, a new endpoint, which is that they want to make sure that they get great coverage so that they've seen the entirety of the colon, and that they believe that that will ultimately drive a reduction in mortality and morbidity, and it's a new quality metric for them. So you're actually changing what it is that medicine is trying to measure by introducing new technologies and new tools. And I think that a lot of what I think some of our successes over the next 5 or 10 years are going to come not just from pushing AI into the parts of the workflow where we expected it, but by really working with care teams to understand where is it going to make the biggest difference. And so, while I really do believe that we've come a tremendously long way, I think we've much further to go still. And that's why I'm so glad that you're all working on this. I think it's something I really hope it makes a difference for Astra and for my other kids. And it really is about building a better world. And with that, I'll take as many questions as there's time for.
Thank you, Greg, for such a such a remarkable and inspiring presentation. Thank you so much for taking the time to share with us your insights and the efforts that you do at Google Health AI on improving the quality of care for patients. So we have time for a few questions from the audience here and also remote participants. Okay, any question? Yeah. Yeah, please go ahead, Garth.
All right. So Greg, you've done these engagements with various sites, and they've installed technology. What would you want to say to them at the beginning to prepare them for this experience, and how to best utilize the innovations that the AI team is trying to bring?
Yeah, I actually think one of the most important recommendations is I think that they shouldn't assume that everything about how workflows will change is understood, right? That feedback early about that we're missing something, or that the technology is being used in a fundamentally different way is really important. Like, we actually had a case where through, for example, the kind of online post-market monitoring, we noticed very different utilization statistics, and we discovered that one of the sites had just started using the tool in a very different way, and it was not really a way that it was designed for, and that wasn't communicated in advance. So I really think it's about be communicative and don't, I think in some ways you have to both, respect each other's expertise and respect each other's ignorance of how things work, because fundamentally this is about intersecting two fields that are very different and have very different natural frequencies and educational paths.
Thank you. Okay, Shams.
Thank you for the great talk. I'd love to hear a bit more about post-launch and what that looks like. If you can talk about a bit more, things like, is there a retraining? How do you monitor shifts? Things like that. Thanks.
Yeah, that's a great question. So this is I think one of the areas of largest impedance mismatch is that at tech companies, right? We are used to cloud-based products where your software services, where you're constantly monitoring all kinds of metrics about the health and utilization of your tooling, and even relatively advanced medical device companies are only just moving their technology into the cloud for the first time. They're not used to the idea of continuous monitoring or post-market surveillance, as it's sometimes called in healthcare, which is a very scary way of saying it. I actually think that there's a lot of opportunity to learn and share and discover. And this is an area where actually some of the best advice that we could get were from folks at Google who work on traditional AI and machine learning products and understand, well, okay, what are the things that you look for in order to understand how well a system is performing? How do you track and aggregate metrics? How do you make sure that there are humans in the loop that are looking at how things are changing? In terms of retraining and relaunching, so in general for real world products, I typically recommend not continuous online updating of models, but actually instead to have a release process where you version models retrained on different data, and only have those releases periodically, and that where you're actually trying to account for a better representation of data. I think in some of the cases that where things fail, there's sort of this false assumption that when you first turn it on, it's working all right. it actually can be the case that you launch on a site where, for whatever reason, the data schema or different, or something is plugged in the wrong way. Like, anything can happen in the real world, and you have to be able to identify those anomalies in a way that's scalable, right? Because you may be working with hundreds or thousands of sites, and so you don't want to be actually like trying to look at the data. And this is further exacerbated by, of course, you want to maintain as much privacy as you can, and so there are relatively strict requirements on who can audit data and how, and that's something that's that I think adds an additional wrinkle. But I believe that the practices, the ideas of what the practices are now relatively common in the tech industry, but they're not familiar to average academics, and they're also relatively new to healthcare, even device manufacturers.
Great. Thank you so much, Greg. We are right on time. We are grateful for the time and effort you took to share your thoughts and insights with us today. Thank you so much.
Thank you. It was a pleasure. Cheers.